Hello, it's me, Winnie the Pooh. No, it's not. It's me, Mr. Newbold. What's up? How's it going, guys? Didn't expect that, did you? So, what we've got going on today is graphing rationals, like I promised you, to help you with that homework assignment, because it was a bit more difficult than we had hoped it would be. But not too bad once you practice and get the hang of it, just like other things we've learned in math. And so, we're going to start off with number 1. Actually, start with number 2, because I think we already did number 1 in class. So here's number 2. And so I would highly recommend that you start off with vertical asymptotes and horizontal asymptotes. Usually you have to simplify it first and do the wholes, and then x-intercept, y-intercept, vertical asymptote, horizontal asymptote, domain range. Then you're all done and graph it. But in this case, we see it's already in simplified form, so we don't need to simplest form, so we don't need to mess with that. So what is the, let's see here, what is the vertical asymptote? That's our question. What's the vertical asymptote? And so the vertical asymptote has to do with this denominator part. And so what is going to make this value, or what value will that be, right? In fact, just to make it easier, you can just follow the rule of just setting it equal to 0, right? So we're going to just take x minus 2, the denominator, and set it equal to 0, and then find out what x is. And that'll be your vertical asymptote. So we're going to go ahead and add 2 to both sides like that. There we go. So you guessed it, it's 2. X equals 2. Okay? So that means our vertical asymptote is going to be x equals 2. Nice. X equals 2. Now let's see here, vertical asymptote x equals 2, and then the horizontal asymptote, if it's a simplified equation only, right, then you can do this, and it's going to be the number that's connected to the equation. Remember, this is only if it's a simplified equation like we've done in the past. Excellent. And so it's going to be 0, because this number right here is the horizontal asymptote, the h of a. So if I was to go ahead and spell that out for you, the horizontal asymptote, 1s asymptote, is x equals 0. Okay? So then, excelente. So what we're going to do is we'll go ahead and take that information, and I'm going to bring it down here. Horizontal asymptote equals 0. Okay, so then do we have any holes? Well, holes is only if you had something like, I don't know, x plus, let's see, x plus 3, and we had that on top, as well as having that in the bottom. So if we had this on top and the bottom after like factoring it or something, and then we cross them out, then that would be our hole. But because this is already simplified, that means that we have no hole there. So for number 2, we're going to put none. Okay. For the x-intercept and y-intercept, do you remember what we do there? We're going to go ahead and set the opposite. So set y equal to 0. Okay. And so for the x-intercept, well, we already know the horizontal asymptote is at 0, don't we? So that means, let's go ahead and graph that. So if the horizontal asymptote is at 0, then that means that it's never going to touch the x-axis, or in other words, it's never going to touch the what? The x-intercept. Okay, so for the x-intercept, we'd go ahead and say none for this particular one. If you set it equal to 0, if you set y equal to 0, you'd end up multiplying x minus 2 to both sides, and then it would be 0 is equal to 3, because the x minus 2 would multiply with the y, which is 0. And so then you'd end up with just, let's see, you end up with just 0 equals 3. And since that doesn't work, since 0 doesn't equal 3, then you just say none. But you can see it doesn't come across there. And then while we're at it, the vertical asymptote is not at x. Wait. Oh, Mr. Newby, you already messed up. It's not x equals 2. What is it? y equals 2, right? Because, no, wait a second, vertical, wow. Vertical asymptote is up and down, and that's going to be here at x equals 2. That is correct. So we need to change our answer for horizontal, because if you graph it on your graphing calculator, y equals 0, y equals 1, y equals 2, y equals 3, that's the horizontal asymptote. There we go, so that's better. And there we go. Now the y-intercept could help us graph. Does it go this way like this? Does it go this way? Or does it go this way? Does it go this way? So then the y-intercept can help us graph it. Right? The y-intercept can help us graph it. So let's go ahead and get the y-intercept, and that'll help us graph it there. And so for the y-intercept, we're going to go ahead and set x equal to 0. Set x equal to 0. And so in our equation, we get y is equal to, let's do a comma there. So y is equal to 3 divided by, so look at our equation there, parenthesis, 3 divided by x equals 0 minus 2, like that. Excellent. And so when we do that, let's see here, what does that reduce to? Well, it's going to be 3 over negative 2, right? 3 over negative 2 is going to be our thing there. Let's see here, 3 and then negative 2 goes down below. So then our y-intercept is going to be, here's our 3, our 0 goes away, just leaving us with 2. So it's just going to be 3 over negative 2. And that's going to be our y-intercept. So it's going to be like, what, 1.5? So we're going to go down to 0, x equals 0 now. And so we're going to go down to x equals 0. So we're going to go down negative 1.5. So right there. Wow, that's a big smiley face. And so then that's where we're going to graph it then. So our graph goes in that quadrant as well as the other quadrant there. So we're going to go ahead and let's go ahead and get our rainbow, your favorite. Make sure it's small enough. Okay, so this is how the graph is going to go then, cutting through that y-intercept, following along. There we go, cut through there. Maybe a little bit higher, do you think? So here we go, following along the asymptote till we get to about 1.5, so that's about there. And then going down, down, downward. Going down, down, downward like this. There we go. And then continuing downward. And then going to the right. And there's our graph there. There we go. And so we've all got to do now is the domain and range. So the domain is x value. So at 2 is our only problem there. So at 2, we're going to go ahead and go like this. We're going to go for the domain. So we're going to say, let's see here, so x is all real numbers except x cannot equal 2, right? So we can just say that if we want to. X cannot equal 2. Another thing we could do is, there we go, that's supposed to be x cannot equal 2 there, which it is. Let's make the equal sign a little bit bigger. There we go. Beautiful. Okay, the other thing we could say that you're probably used to is if you wanted to, yeah, look, there's Panda. What's up, Panda? Good dog. Okay, so there's x equals 2. So another thing you could say is what? You could say, you know, negative infinity to 2, close parenthesis, and union with, open parenthesis, 2 to infinity. So that's another way you could write it if you want to. Either way is okay with me, and will be okay in calculus and 1050, 1060, I think, as well. And then what we'll do here is we'll go ahead and change these to infinity signs. There we go. A bit bigger for you. So either of those will be fine to help you out there. Boom and boom. There we go. Okay, and then the range will be y values. So y is all real numbers except for what? Except, well, let's see. So here is our y values. Here's my range coming from negative infinity And then we're going to be coming up this way. Uh-oh. Then we got to jump over it and then carry on. Right? And so right there's our exception is what we have there. So we're going to say that y is all those values except y cannot equal 0. And that's the line y equals 0 there. So we'll go ahead and grab that there just like that. Excelente. There we go. Bam. Except y cannot equal 0. Sweet. So there is number 2 done. Now let's just go to a harder one there. Let's see what time we're on just to make sure. 10 minutes. We could probably do one more and call it good. That should help you a lot, right? We could do this one if you want to. Number 3. Should we jump to maybe a harder one in the back? That looks pretty good. Number 6. Yeah. Okay, so then look at this one. So this can actually factor, can it? So we're going to go and factor that. Let's see what it factors into. Let's see here. So we're trying to get the simplest form, but this is also going to give us the wholes too. Wow, I can't see. There we go. X squared plus x and minus 6. So what's that going to factor into? Let's see here. There we go. Okay, so that's going to factor into what? X and x. What else is going to factor into? Is it 2 and 3 or is it 6 and 1? That's the question. Well, we need the middle term to add up to be a 1. So I think a 6 and 1 would give us 5 or 7. Ooh, but a 2 and 3 will work here. Okay, so here is a 2 and a 3. Excellent. And which one's positive? Which one's negative? Well, if you see here, the middle term here is, right, the middle term is positive, so that means we want the bigger one. That means we want the bigger one to be positive. If it lets me. There we go. So we're going to make the middle term there positive, and then we'll make this term negative. Excellent. So now that we've factored it, that hopefully will help us here. Okay, ooh, so now that we factored it, I thought 6 would be in there, right? 3x minus 2x is 1x. Yep, negative 6. That's right. So, so simplest form, kind of, yeah, I guess it is. So we'll make that a little bit smaller so we can fit it in the simplest form there. And then we'll go ahead and do a line like that. Excelente. And then x plus 6 on the top. There we go. So now we're going to go ahead and we've got the simplest form now, and now we're going to do these things over here. So it looks like wholes because nothing canceled out. Still, I wonder if one of them will be a whole or not still. Interesting. Let's see. Because it's still, one of them will be undefined, and one of them will be the x-intercept, y-intercept. So first, let's go ahead and do the, let's see, vertical asymptote, horizontal asymptote. So the vertical asymptote would be setting each of these equal to 0, or finding the number that would make it a 0, right? You can set them each equal to 0 if you want to. But I can already see that negative 3 here would make the whole thing equal to 0. So that's one of them, right? X equaling negative 3 is going to be a problem, right? Can't equal negative 3. And also it can't equal what? Negative 2. So those are going to be our vertical asymptotes. What? There's 2 of them? I know. So we're going to say our vertical asymptote is at negative 3 and at x equals 2. Okay, so what we'll do there is we're going to grab the rainbow pen, your fave. Let's try a different one this time. Okay, and then we're going to go at negative 3. So here's negative 3. There we go. Wow, that's not a straight line, is it, Mr. Newbold? No, it's not. Why don't we do a straighter line than that by using maybe, I don't know, this cool thing. Here we go, straight line. So there is our horizontal asymptote at negative 3. And at positive 2, there's another one. Now what about our vertical? No, that was a vertical, sorry. Now what about our horizontal asymptote? So horizontal asymptote, remember, it's if there's a number plus in front of it. But I don't really see a number in front of it, so interesting. There we go. So I'm thinking that we'll probably need to look at our x-intercept and y-intercept first. What do you guys think? Yeah, let's do that first. Okay, I don't really see any holes because nothing really canceled out, but I still wonder if one of those, because we have 2. Yeah, so both of them are there. Nothing canceled out. So yeah, I'm wondering if those are just it, and there's not even going to be a holes, I'm thinking. But let's go do the x-intercept first. So the x-intercept is set y equal to 0 and solve for x. Okay, and so when we go ahead and set y equal to 0, that means we're going to make this 0 right here, right? 0. Wow, that's a big 0. And then solve for x. Well, how in the heck are we going to solve for x there? Well, let's do it down here. So what we're going to do is we're going to take our simplest form there. Okay, we're going to go ahead and group it together. Nice. And then we're going to copy it and paste it down here. Okay, so for our x-intercept, we're going to set y equal to 0 now. So that means that this right here is going to equal 0 like this. And then we're going to try to solve for x. Well, what we'll end up doing is getting rid of the bottom and solving for x by multiplying both sides times getting rid of the denominator, x plus 3, right? Wow, that shouldn't erase that. Wow. So we're going to go ahead and, let's see here, multiply both sides times x plus 3 and x minus 2, like that. Okay, so we're going to multiply both sides by that. And what that'll do is you multiply it on the top, you got to multiply it to the left side of the equation, or the right side of the equation, and you got to go and multiply it to this side of the equation too. Okay, and so 0 times anything is just 0. Yeah, and then this will cancel out with this one. So all that will be left is 0 is equal to x plus 6. And then we go ahead and solve for x. And so we get x is, let's see here, solve for x. So we're going to go ahead and x plus 6, like that. We're going to minus it to both sides, like that. And so when you minus it to both sides, you get x equals to negative 6. So x equals negative 6. There we go. So that's our x-intercept. That is our x-intercept, okay? So then we'll go ahead and do a little line straight across there like that. Excellent. Now we're going to find the y-intercept, and how we do that is do the opposite of y. What do you mean? I mean set x equal to 0. Cool. So then we're going to go and set x equal to 0. Here we go. And so that means we're going to take our original equation again. Okay, like this. And this time, and then we have y equals. And so everywhere we see x, we're going to put a 0 there, right? Put a 0 there. So this becomes 0, this becomes 0, this becomes 0. Because when x is 0, then we get a y-intercept. I guess we should put our x-intercept when we're talking about it right now anyways, right? So x equals negative 6 is going to be our x-intercept. So 1, 2, 3, 4, 5, 6. So here is our negative 6 there. So when y equals 0, x equals negative 6. Cool. And then when x equals 0, y equals what? Well, we got a 0 goes away, so we're just left with 6 divided by 3 times negative 2. And 3 times negative 2 is negative 6. And 6 divided by negative 6 is just a negative 1. Cool. So then, when x is 0, y is negative 1. So that's going to be right here is another one of our intercepts there. Cool. Now holes. Holes is only if stuff cancels on the top and on the bottom and gets rid of one of our asymptotes. Because then our asymptote becomes a hole basically. So for holes, we're going to put none, which is kind of crazy, right? Yeah, that's crazy. And then our horizontal asymptote, I'm not even sure if we have one, I wonder. Interesting, right? This is crazy with the dot here and here. So let's take a look. So if I had a graphing calculator, which I have on my laptop, I could graph this and see what it looked like. That would help us out a lot. If you don't have a graphing calculator, like some of you don't, that's why you're watching this video. Let's see. Well, how would this work? We could plug in some points. That would help us a lot. Maybe plug in 2, for example. Let's see. How about at negative, right close to the asymptote? I'm thinking we're going to do something funky here. This one's going to be a funky one. So let's go ahead and plug, I want to plug in not a 2, because that's 8. 2 squared is 4 plus 2 is 6. So that's undefined. Yeah, 2. What about a 3? Let's plug in a 3 there. And that's always an option if you don't have a graphing calculator, just to plug in the points. So we get 3 squared is 9, plus 3 is 12. Don't forget the 3 up here. So then we get 9 over 9 plus 3 is 12. 12 minus 6 is 6. So 9 6, which reduces to, I think you can divide by 3, divide by 3. And so that becomes 3 halves, 1.5. So at 3, 1, 2, 3, it is 1.5. Cool. Let's try another one now. I know you all wish you had a smart board to do this, but you can just show your work and write it all over again. And let's do green again. So let's do 4 now. What happens at 4? So at 4, we get 10 on the top. And on the bottom, can you do it in your head? 4 squared is 16, plus 4 is 20, minus 6 is 14. And that reduces to divided by 2, divided by 2, so 5/7. So that's not quite even 1, because 7 over 7 is 1. So not even quite 1, so it's going to come down here. Cool, interesting. So now what happens at, I wonder what else would make this 0. Let's see, a -3, a +2, so -3, +2. What about the horizontal asymptote? Well, what about when, oh no, we have it right here, so it's not there. Interesting, huh? What about 1, 2, 3, 4, let's plug in a 5 and see what happens. 1, 2, 3, 4, 5. Let's put a 5 in there, okay? So we're going to go and put a 5 in there, and we get 11 over 5 squared is 25, plus 5 minus 6, so that's 30, minus 6 is 24. Wow, that's almost to, let's see, 12 would be a half, so it's almost a half. So at 1, 2, 3, 4, 5, so it looks like what we're going to have here is we're going to have a horizontal asymptote right here along y equals 0. But what's crazy about that is over here it doesn't seem to be that way, does it? Interesting. Because at 1, so at 3, 4, 5, 6, we had, when we set equal to 0, we had x equal -6 there. Oh yeah, because you put a -6 in there, you get 0. Yeah, cool. So now let's see. So that goes that way. Let's pick a point right here maybe at -2. Okay. So this is just because if you don't have a graphing calculator, this is what you're going to have to do. If you have a graphing calculator, you can just plug it in. So -2 squared is going to be 4. Minus 2 minus 6. Okay. That's going to be a positive 4 now, because -2 times -2 is a positive 4. There we go. Okay, and then we'll put in a -2 up here. So that's going to be 6 minus 2 is 4. All over -8, and positive 4 is -4. So that's going to be a -1. Interesting. So at x equals -2, we get y equals -1. Interesting. So we're going to go -2 and then go -1 right there like that. Boom. Okay, so now I wonder what's going on. Isn't that strange? Interesting. Okay, it almost makes me wonder what's going to happen here. Yeah, it does. Okay, so then let's see here. We're going to pick another point. How about, let's see here. I guess we could just put in a 1. That'll be pretty easy, won't it? Okay, so we're going to erase that here and put in a 1. Can you do it in your head? Good question. Can we? 1 squared. I think we can. 7 over 1 squared is 1. 1 plus 1 is 2. Minus 6 is -4. Ooh, -7/4 is a big number. So almost -1.5. So at 1, it's almost -1.5. What about 1.5? That's going to get tricky. So we're going to go ahead here and do, let's see here, so negative 1.5 would be like negative 3/2 everywhere. So that's going to be a positive 9/4. Okay. Minus 3/2, minus 6. Let's change 6 to halves. What's 6 halves with half? Well, 2 times 6 is 12. So that'll be on the top, and then on the bottom will be 2. Is that right? 12 divided by 2 is 6. Nice, nailed it. And then we're going to put negative 3. We're doing negative? No, it's just going to be here. We don't do negative. Let's do positive. Mr. Nobald. Why do we do negative? Whoa. Okay, so now we're going to put a positive, right? We're going to, what's going to happen at 1.5? So positive 3/2. Positive 3/2. 3/2 squared is 9/4. Do you remember you like doing fractions? So 3/2 squared is 9/4. And 9/4 plus 3/2. What's 3/2 is a 4? Well, if we multiply this by 2 and multiply this by 2, right? We get not squared but multiplied is 3 times 2 is 6/4. So 3/2 becomes 6/4 minus 24/4. If we multiply the top and bottom by 4, turned into fourths, we get negative 24/4. Cool. So that's 9 and 6 is 15. And then a minus, so it's going to be a minus 9. That's supposed to be fourths, sorry. Minus 9. Let's see here. That's 6 and 24 is negative 18. Yep. Yeah, minus 9/4 is what we've got on the bottom. On the top, we have 3/2. Man, I should get my calculator out, huh? 3/2 plus 6. Okay. Turn them both into halves up here, even into fourths would be better. So that's going to be what again? 6/4 plus 24/4, 30/4. So now we have 30/4 divided by negative 9/4. But if we flip it and multiply by the reciprocal, so we go times 4/9, the 4's will cancel, leaving us with a negative 30/9. And that can reduce to a negative, finally, 10/3. Holy cow, that's crazy. So it's just going to get bigger and go way down here at 3 and a bit. 1, 2, 3. 10/3 is 3 and a bit. So I'm thinking it's going to be going this way, like this. Okay. And we can, like I said, you should already have this video stopped. If you already looked at your graphing calculator, you got the answer, and so forth. So I don't think there is even a horizontal asymptote, which sounds crazy, doesn't it? But if that's coming up this way, I'm pretty sure it's going to come up this way. But I wonder where our horizontal asymptote is at. What we're going to do, just to double check, because this is kind of the first time I'm teaching this, is we're going to go here and take a look at number 6. Because I got some help there with that to help you. Here we go. Let's see here. Go to our computer. There we go. Let's just take a look at the very last part. Because I'm thinking to myself, there should be an asymptote. And if we can plug points in, that's probably the easiest thing is what we should do to see what happens there. Plug a point there, plug a point there, see where it goes. But you know how to do that, hopefully. And so, but let's just go ahead and see how close. Hopefully we got all this right. Graphing rationals with our help from Mrs. Cassidy. Here we go. She helped us out there. And that's our simple. So I need to close that actually because I've been working on fixing that for her. Fixing that worksheet there. So the one we're looking at is actually this one. There we go. Sorry that's taking so long. Where are we at already? Oh man, it's already been that long? Doesn't feel like it. 30 minutes we need to end this video. That's crazy. Hopefully you fast forward it. Please fast forward, because for some reason my computer's being really slow. Maybe I'll pause it for a second. Let's just pause it so you don't have to wait any longer. Be right back. Alright, so that was cool. Froze time there for you, but I was actually time traveling. And so what I researched and figured out is this is correct, what we've done so far. And then what's going to happen is that our graph is going to come down and curve. And this will work as you plot in points for negative, let's see, -3, so -4, -5, -6, -7. So we do have a horizontal asymptote at y equals 0. And how we know that is that rule that I talked about before in class. What rule is that, Mr. Newbold? So the rule of that, in case you weren't there in class, let me show it to you one more time. To tell us about horizontal asymptote, remember from Nancy. What's up, Nancy? Yeah, hi Nancy, what's up? So she helped us out here. And so if the top degree is less than the bottom degree, the horizontal asymptote is y equals 0. Interesting. And so in our case, and if you want to write this down if you haven't seen this before, if the top degrees equal each other, then it's just the number in front of it. Like 1/3 is what happened there. 1/3 is the horizontal asymptote. And if the top degree is greater than the bottom degree, then it's going to be no asymptote at all. But if we go back to our original problem there for number 6, then you'll see, let's go back to the original problem before we simplified it, right? Back to the original problem there. And back to the original problem, when we look at that, it shows us here that x squared is larger than x to the first power, right? And so that means that since we have little over big, then our asymptote is going to be at y equals 0. So we're going to go to our asymptote here, horizontal asymptote, and we're going to say y equals 0. Excellent. And then, let me just get that, and the oven timer's going off. I'll be right back. Alrighty, we're back. Thank you for your patience. Just recording the Grammys for my wife. So it turns out that our horizontal asymptote, because we have the top highest power is less than the bottom highest power, according to Nancy, then because of that, then we have our horizontal asymptote equal to 0. And so let's go ahead and draw that horizontal asymptote. We should have done that first. Sorry about that. We'll go ahead and put that right here. And let's make it a different color. How about red? We like red. Christmas. Okay, now the crazy part is that it does, so it does touch right here. And it actually goes through the horizontal asymptote. So this is kind of a weird equation is this one, right? Kind of weird. And so what happens is that it comes down like this, like that, and then it cuts through there, but then it goes along and doesn't touch it anymore. So number 6, I'm glad we did it together because it's kind of a really weird one, and probably have to do this one in class again. But that's what this graph looks like. Pretty weird graph, huh? Yeah, it does cut through there because, as you know, at -1, 2, 3, 4, 5, 6, at -6, and -6, we do get 0 in the top and some number that's okay in the bottom. What is that? -24. Let's see, -18, and -6 down here would be -8. No, -6 plus 3 is -3. And right, -6, x equals -6, so we get -8 plus -3 times -3 is a positive 24, but then we just have 0 on the top. And so it doesn't matter that it's positive 24 on the bottom because we just get at 0, and 0 is 0. So then when x equals -6, we get y is equal to 0. And so that's right there. So it does cross through. Kind of see here in our solution guide that for 6, it comes down, up and around. Whoa. And then it comes down to the left. What a weird one. Okay, so we'll definitely have to look at some more of these. So I'll do another video for you guys. And so it turns out that this line is actually a little bit different. Yeah, that's crazy, huh? So I guess we shouldn't have just assumed that it went up, should we? Because at negative 2.5, it must come down to here. So we're going to come up here. That's why the graphing calculator really, you guys, is the best method for these. Okay? So there we go, and I will see you in a second on doing another video, one that has holes in it. So thanks for watching, and I'll see you on a shorter video next time in a second. You take care and have a good night. See you later. Don't forget. Goodbye. I love honey. Is that Tigger? See ya. Bye.